All right, we're going to be talking about solving equations. We got a few key ideas here. Let's scroll through them real quick. We got equality, getting x by itself, addition property of equality. Notice there's going to be a double there, and then checking your answers. So when it comes to equality, there's no better way to talk about equality than to talk about my cookie and your cookie. See any problem with that? This one's mine, and this one's yours. Do you see any problem? I bet you do, because these, if I were to put an equal sign in between them, you would say, yoink, there's no equal sign in between there. They are not equal. So, hang on, would it change anything if I said that this was your cookie? Hopefully you would say yes, because I literally copy-pasted these two. These are the exact same size. That is what equality means. And how we are going to represent that is, I mean, obviously we represent it with cookies, but one way we can represent that is we can say that, hey, what if x equals 7? So then what that means is that this is like one cookie, and this is like the same cookie. If you're like, what does that mean? This is what I'm talking about. Okay, is that if things are equal, they're basically the same exact cookie. You have one on, let's call this like the left side, and you have one on the right side, okay? And sometimes we have to do stuff in order to solve, in order to figure out what that is, and that's what we're going to be doing right here. Is in this key idea, we're going to be solving, okay? And how do you solve? Well, you solve is getting x by itself, okay? And so that idea is going to rush straight into the addition property of equality. But the reason that you can get x by itself is what we did the other day, where we had the seesaw, right? So here was the seesaw, and there was this, 12-pound weight over here. There was a 7-pound weight over here. And then there was, I'm going to try and draw a little puppy. This is not going to go well. Okay, there's the puppy. And so if this is a seesaw, and this seesaw right now is flat, or at least supposed to be, then you know that this puppy weighs 5 pounds, right? Because, I mean, of course it does. Because you know that 7 plus 5 is going to be equal to 12, right? But let's pretend that somehow you didn't know that, right? And what we're going to have to do is erase this. And what we'd also have to do is we're going to have to erase this and erase this. And the idea is that now, okay, this 7-pound weight is really like 7 1-pound weights, okay? That right there is 7 pounds, okay? And then over here on the right, what did we say? It was 12, I think. So here, we'll cut it up. And then there's 1, 2, 3, 4. We'll do it again. All right. So we have 1, 2, 3, 4, 5, 6. I did too many. All right, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. This is 12 pounds. And so what we're going to have to do is the dog is just going to have to chill here. Oh my gosh, and it's still the ugliest looking dog that I've ever drawn. Here, if I give him a little profile view, that will help my situation some, right? There's the profile view, he's like looking to the left. Anyway, here's what we're going to have to do is, what we do is we go, okay, well, if I could remove this weight and remove that weight, as long as I remove one from this side and then one from this side, we'll be okay. Remove one more, 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 one more. And how many, we now have the dog is by itself, right? And on the right side is 1, 2, 3, 4, 5 pounds. And that's what we said, that the dog was equal to 5 pounds, right? Okay, so that's getting x by itself. And here's where, like I said, this property was going to speed over here, okay? The addition property of equality is like this. If I had x minus 4, and that were to equal, let's go with 9. The addition property of equality says we are going to, well, hang on. First thing I want to do is I want to draw this line. I don't think I've done that quite yet because we haven't had, oh yeah, I did it right here. I drew this line here because I want to establish we have a left side and a right side, okay? So right down here, we have our left side and we have our right side, yeah? What's happening is we want to get x by itself, yeah? We want to isolate the dog so that we know exactly how much it weighs. Well, so if we are going to do the addition property of equality, what's going to happen is we're going to add 4 to both sides. Why this might feel a little strange is that right here, when it comes to a seesaw, you've never experienced, like negative weight, right? But imagine that there was like a little dude underneath the seesaw and he was holding up, I tried to change colors, let's do it again. And he is holding up the seesaw. Oh my gosh, this is the best drawing I've ever drawn. Yep, he's trying to hold it up. He's like, I'm holding it up. Like if he's holding it up for like 4 pounds worth, then that's kind of like -4, right? So anyway, we could also think of it like with emotions and stuff, as we've been doing, right? Right. So right here, we're going to add 4 to both sides. What's -4 plus 4? It cancels out. And the idea behind the addition property of equality is right here, I'm adding 4 to this side. If you add to one side, you can probably fill in the blank of what I'm thinking. You must add to the other side. So if you add to one side, you must add to the other. And here's what we end up getting. This x is all by itself now. That was our goal, was to get x by itself, right? And now we have 9 plus 4 does not equal 0. -4 plus 4 equals 0, right? But 9 plus 4 equals 13. And so here was the situation. We had some number, we had some box, and we knew that if we took 4 away from it, that we were going to have 9 left over. So then how many had to have been in that box? 13. Okay? That's the addition property of equality. So let's just come up here because I drew this earlier. What I did, and I honestly kind of forgot that I did this, was I drew a box of like, hey, here are exactly 4 cookies, right? And then this is unknown amount of cookies. You can't tell, you can't look in, you can't see, you don't know, right? So that's unknown. If you look here, I mean, there is 1, 2, 3, 4 cookies. I mean, it's pretty obvious. So what if I told you that, hey, listen, if we were to subtract, let's say, 8 cookies from this box, it would be equal to that box. Well, if that's true, then this is where that addition property of equality comes in. We add 8 over here, and they cancel. If we add 8 right here, we would go, oh, 4 cookies plus 8 cookies, that's 12 cookies. And so we would automatically go, hey, if you were to put 12 cookies inside of this box, it would now be equal to an entire box of unknown cookies. So how much is in a box of cookies? 12. 12 equals 1 box. Okay, that was the addition property of equality. There's another, so remember I said there was a double key idea here? Here's the other idea. There is the subtraction property of equality. And we're not going to leave much room here because it's the same thing as this, but with subtraction. Okay? So the subtraction property of equality looks like this. If I had x plus 7 equals 11, how are we going to find this? We want to make sure we have the left side and the right side. We are going to subtract 7 because we want to get x by itself, right? If I do it to one side, if I subtract on one side, I must subtract from the other. These 7s cancel. That x drops down. And 11 minus 7 is 4. So again, if I don't know this number, I don't know it, but I add 7 to it and I get 11, you know this, and lots of people know this, that it must be 4, right? Those two must be the same. So here's where I've said it. I probably should have said it 12 minutes ago because this video is now 12 minutes long. You must have these basics, okay? You have to know that, oh, hey, x plus 7 equals 12. Yeah, we're going to subtract 7 to get x equals 5. Oh, we have x minus 4 equals 9. You have to know that when you add, you're going to add 4 to get x equals 13. You just have to know it. These are the basics, okay? So if you're like, this is so easy, I'm not going to do this. It's going to look. It's gonna look. That says gonna. I also realized I hit undo so you can't see. It's gonna look much worse later, okay? It's gonna look much worse later. When you see a little kid bouncing a basketball, you think, I could take that little kid. You see LeBron bouncing a basketball, you're not gonna be able to take him, okay? So check your answers. This is like the final thing. How do you know when you're right? Okay, well, so x minus 21 equals 11. First thing, I'm going to separate it into the left side, the right side. I'm going to add 21 to both sides. The 21s cancel. How do you know that you were going to add 21? Because we want to get this guy alone. And negative 21, how we make him go away is we add him, okay? And we now have x equals 32. And if you're thinking, okay, yeah, I knew that. Well, sometimes you're going to go, wait, is that the right answer? And I'm going to say, well, have you checked your answer? Here's how you do that. You take that 32 and you plug it in right there. It's kind of like you say, if I have a box of cookies and I take away 21 cookies, I'm going to have 11 cookies left over. Okay, well then, if that box started with 32 cookies and then I remove 21, does that truly equal 11? Does it? If it does, then you're good. If it doesn't, then you did some math wrong here or maybe here, right? It's possible because I've seen it happen that people just make a mistake, okay? So you have to check your answer to see if your mistake is right. So what are you going to do to solve equations? Well, 1, you're concerned about them being equal. 2, you're going to get x by itself. And then how are you going to do that? You're going to do it by adding and subtracting, keeping this sense of equality. And if you're like, what is that sense of equality? That sense is If you do it to one side, you must do it to the other. Okay? Okay. Let me know what questions you got.